Hello, welcome back to another Roblox Let's Play. Today we're going to be doing our fourth concept on transformations, and that's dilations. Dilations are basically a size change in a shape. So here you can see three different triangles. They're all similar, but they are different sizes. So let's go a bit more into detail about how you can dilate a figure. So when you do dilations, there's a point called the center. The center point is basically where you dilate from. So there's a rule for dilations, and that's if, say you have a scale factor of k, the distance from the center to the image point, so let's say there's an image point somewhere out here, is the same distance from the center to the pre-image point times the scale factor. So let's say that this distance right here, PA, is 1 inch. Then the distance from the center to whatever the image point would be PA times the scale factor. So if the scale factor was 2, then the distance from the center to the image point would be 1 times 2 equals 2. So let's try and practice once here. So let's say we want to dilate this triangle from the point of P with scale factor of 2. So basically, the way you would do it is you just need a straight edge. You place your straight edge so that you can draw a segment that contains both the center and the point you're trying to dilate. Then you draw a line. Sorry, you're drawing a ray, not a line, because another one of the rules is that the pre-image and the image points are on the same ray. And that ray has the endpoint of center. So this is the ray that's going to contain the center, the pre-image, and the image point. So the next thing that you do after drawing the ray that contains the center, the pre-image, and the image points is to put your straight edge on that ray. And since we know that the distance from the center to the pre-image point times the scale factor is the same as the distance from the center to the image point, then all we need to do is multiply this distance right here by the scale factor. And since the scale factor is 2, we're just going to copy this distance one more time over here. So this distance right here is 1 inch. We'll move it over here, and we'll copy 1 inch. So 1 inch would be right here. So as you can see, this distance right here is 2 times that of this distance right here. So if this has a distance of 1 inch, this has a distance of 2 inch. And let's say the scale factor was another number, 3 or 4 or 5, then you would just copy this the appropriate number of times. So now this is one of our points, and we'll just repeat that for each of the other steps. So when you're finished, you should get a figure that is similar to your original pre-image, but it's now either bigger or smaller, depending on the scale factor. So if the scale factor is greater than 1, then your image is going to be bigger than the original. If your scale factor is lower than 1 and greater than 0, then it's going to be smaller. And let's try that right now. Let's say that instead of 2, the scale factor is 1/2. So when your scale factor is smaller, the rule still applies. The distance from the center to the pre-image times k is the distance from the center to the image. But now since it's less than 0, we have to multiply this distance right here by 1/2. So you would basically just cut this distance in half. So that would be right here. And you would repeat that for each of the other ones. And now you have a dilated triangle that is 1/2 the size of the original. And if this scale factor was 1/3 or 1/4, you just divide it into thirds or fourths or fifths. So to review, in order to dilate a figure, you just need to draw a ray that has the endpoint of the center and goes through each of the pre-image points. Then you need to multiply the distance from the center to the pre-image points by the scale factor. So if it was 2 or 3 or 4 or 5, if it's any number greater than 1, you'll multiply by that number by copying it that number of times. So since it was 2 over the first time, we did it twice. If it's smaller than 1 but greater than 0, then you divide it by the appropriate number. So if it's 1/2, you divide into 2. If it's 1/3, then you divide into 3 parts. And then you just repeat that on each of these rays. And then you connect the dots and you get your dilated figure. So here's something else interesting about dilations. This triangle is being dilated from 2 different points by the same scale factor. Both of them are dilating with a scale factor of 2. So if you dilate by scale factor of 2 from this point, you get this triangle. And if you dilate by scale factor of 2 from this point, you get this triangle. And you can see that these triangles are congruent because you dilated them with the same scale factor. Both of them are times 2. But you can see that they're in different places. So the location of the center determines where the image will go, but not the size. The size depends on the scale factor. So now let's go on to see what would happen if we were doing dilations on a coordinate plane. So on a coordinate plane, it's really easy. If you have a scale factor of k and you want to dilate a point x, y, then you just multiply each of the coordinates by the scale factor. That's it. And generally, when we're talking about dilations on a coordinate plane, we assume that the center is the origin, right here. This only applies if the center is the origin. So let's say we want to dilate this segment right here, 1, 2, and 2, 2. So the only thing we would need to do is multiply both of them by the scale factor. So let's say the scale factor was 1.5. So 1, 2, we would multiply each by 1.5. So 1 times 1.5, you get 1.5, and 2 times 1.5, we get 3. So you would get 1.5, 3, 1.5 and 3, and then the other point, 2, 2, you would multiply each by 1.5 and you'd get 3, 3. So in the end, you would get this, and you can see that it's still oriented the same way. Dilations don't change the orientation, but it's larger now. So remember, dilations are just a change in size. So since this is a pretty easy concept, we'll only do a few practice problems. So let's start with some synthetic ones. So right here, the scale factor is 2, and let's just dilate this quadrilateral from this center. So we'll just do what I showed earlier. We put the ruler here and we draw a ray that has the endpoint of the center and contains the pre-image points. Alright, and then we're just going to copy the distance. So since it's 2 times, we'll just do it twice, or do it once, copy it once. So since the scale factor is 2, we'll copy this distance once. And again, that's because this final segment will be 2 times the length as the segment from the center to the pre-image point. And I messed up the first time, it should actually go right there. If you don't measure it exactly with a ruler, then you can freehand it, but I'm just using it with a ruler to make it a bit more precise. That's 1 point, about a little more than 1.5 inches, so this is 2 inches. I didn't draw the line that long, so that's about a 1 1/4. And then when you're done, you can just connect all your points, and then you get yourself a dilated quadrilateral with a scale factor of 2. So there you go. So let's go into this one where the scale factor is 1/3. So now we're making it smaller. So let's do the same thing as we did before. Draw the rays that have a endpoint of the center and contain pre-image. So now, since we have a scale factor that's less than 1 and greater than 0, we have to divide the segment from the center to the pre-image into multiple parts. Since it's 1 over 3, then we're going to divide this segment into 3 parts. So I think this looks about right. And over here as well. So we have 3 equal parts. Since the segment is supposed to be 1/3, it will be these points. So this is our dilated segment with a scale factor of 1/3. Because this distance right here is 1/3 the distance of this. So if this was x, then this has a length of 1/3 x. So now let's go on to a coordinate plane. So coordinate plane is pretty easy. We just need to multiply the x and y coordinates by the scale factor. So the scale factor is 1/2. The first point is 1, 2. So half of that would be 0.5, 1. The next point is 3, 5. So that would be 1.5, 2.5. And the last point is 4, 4, so that would be 2, 2. And so now we've dilated it by a scale factor of 1/2, about the origin. So remember that when you're dilating, you're only changing the side lengths. The side lengths are being changed by the scale factor. You're not changing the area, you're not changing the orientation, you're not changing the shape, you are just changing the size. And by size, I mean basically just the side lengths. So that was dilations. It's a pretty easy concept. You shouldn't have any trouble with it. Hope I helped.
Wait, I want to have lipstick. That's really... Oh, come here, lock.